Hello. We have one more module to go over before your exam 3. It's called Module 9, Substitution. It includes Class 21 and 22, and in this video, Class 21 was used to introduce substitution. Introduce is in quotes, or intros in quotes, because you've seen substitution already. It's just that at the time we didn't call it substitution. We called it alkylation. Let me give you a reminder. This is actually reaction 19A. And you start out with a terminal alkyne. You add a base. The base that I typically use is NaNH2, or you could also use NaH or LDA. And you need to know the structures for NaH and LDA and how to draw the base so you could use it in the mechanism. The second reagent is an alkyl halide. It has to be a methyl halide or primary, so I'll make this primary. Could you pause the video and fill in the product, and then I'll go over the mechanism. And I think in this video I want to contrast elimination with substitution, and then at the very end of this video I will make assurances to you that if I give you a reaction that could do both, I will ask specifically for either the elimination products or the substitution products. That's the plan for this video. It should be done in 20 minutes, 25 minutes. Okay, the product is this. We attack this blue dot with the last carbon of the alkyne, because the last carbon of an alkyne is a anion after we reacted with base. And what else is connected to this blue dot? We have a CH2, CH with 2 methyl groups. Let's go over the mechanism and explain why this is considered a substitution. Right now, you know this, I think, mainly as an alkylation, but it's also a substitution. The mechanism is, let's see how fast we could do this. You could pause the video also now and try the mechanism. Which base should we try? Let's use LDA. Lithium, but I don't normally draw the lithium because that's a spectator ion. The molecule I'm drawing now is the diisopropylamine, which is a Da in LDA. You use the LDA base to deprotonate the alkyne. I'm really hoping this terminology, such as deprotonate or terminal alkyne, I hope that's second nature to you already. We did create the alkynyl anion and the conjugate, what will this be? The conjugate acid. And next we have our alkyl halide. It's primary. And here's your substitution part, where the bromine is substituted with this stuff. So it's a replacement. Actually, you can think of it as a replacement, but technically it's a substitution. Make sure you have the right number of carbons. The last carbon of the alkyne connects to the dot via a single bond, and I verbalize what's connected: CH2, CH with 2 methyl groups. We kicked out Br, and I think that's it for the mechanism. The substitution part, again, is right at the second step. This is the substitution. Okay. Remember, I'm not going to go over it here, but remember that the alkyl halide has to be primary or methyl. If it's not, then we actually do beta hydrogen elimination. Don't worry about that now. This is 19A reaction substitution. And so let me go over a kind of a dilemma that I didn't tell you about when we talked about elimination, which is the base that helps do elimination could also do a reaction like this, substitution. And let us remind ourselves about an elimination reaction. Let's see. Now I have to look at my notes. Because when did we do elimination? It was definitely for this exam, and it was very early. I think it was, let's see, class 18. Give me 1 second. Okay. This is reaction 18B. It's actually really nice how these seemingly very different modules are now coming together. The radicals, the alkynes, and substitution. They all are intertwined, and the reason why I'm going over reaction 18B, which is beta hydrogen elimination, is that elimination and substitution are typically in competing with each other or occurring at the same time. I'll show you exactly what I mean. Let's say we have this alkyl halide. Let me just make it primary for now. And my favorite base to use is NaOET. And we get elimination at the alpha and beta position. And so if you know you're doing an elimination, go ahead and mark your alpha and your beta. And your double bond will occur between the alpha and the beta. Elimination gives you alkenes. And also alkynes if you do double elimination. But the purpose of showing this again is your NaOET serves two purposes in this reaction. And I'm going to put here and what color? Here. And it does both. So here's NaOET. Let me put here at the bottom what OET stands for. O, ethyl. Like this. And what else can happen? And substitution. So remember substitution? You substitute the halide for the nucleophile. So here's the dot. The O minus came in and attacked, and here's your ethyl. So this is called an ether. And here, the alkene that was produced via elimination. And the ether here was produced via substitution. And look at the starting material for both. They are identical. Okay. We haven't looked at we have seen a mechanism for substitution, but we haven't seen it in the context of a strong base or a strong nucleophile. So listen to what I said. The OET here acts as a base. To remove the beta hydrogen. The OET here acts as a nucleophile. I mentioned dual personality in class 22. There's your dual personality. And so, not for this exam, but for exam 4 and the final, you'll need to know that it's a plus. That these two are made at the same time. So, 50-50, I don't know. It depends on some other variables, but I know that both of those exist. That's for exam 4 and the final. For this exam, I want to assure you that if you are given reagents that could do both elimination and substitution, I will literally ask you to give me either elimination or substitution. I will explicitly say what I want. So a lot of times you'll see something like this. Draw the elimination products. And circle the major one. For the same reagents, I may ask you for the substitution products. And so here, draw the substitution products. Or product. Substitution typically gives one product unless you are making a racemic mixture. So what should I say here? Draw the substitution product or products with proper stereochemistry. Right now, we haven't seen any reaction where stereochemistry is important, because I think neither of these reactions a chiral carbon is produced. It will be important when chiral carbons are produced. You have to know whether you're going to keep the configuration or invert it, or both, which is called scrambled. I'm getting ahead of myself. That's class 22. Let me finish up this question. Draw the substitution product or products with proper stereochemistry and state its mechanism type. In the next video, class 22 review, I'll go over the two types of substitution, SN2 or SN1. And so those are the two types. That's the formatting of how I would ask you to draw the products for a reaction that could possibly give us both elimination or substitution, but for each question that deals with that, I will explicitly ask for either the elimination or the substitution. Actually, there's one more. What if I want both? I may say draw all the substitution and elimination products and label which came from elimination and which came from substitution. So again, I could give you something like this. I will explicitly ask for both. I could explicitly ask for both elimination and substitution products, and underneath or next to it, tell me if it's elimination, or tell me if you got it from substitution. Okay. I think that's it for this video. I know it's short, but I'm saving the mechanisms for the class 22 video. I had one more thing to say. You will not be left guessing if you need to draw elimination or substitution products. I think that's the best way to say it. You will not be guessing. You will know what exactly I want. So don't worry about that.